everybody for joining me at my talk. And again, let me share my screen and let me see, share screen. Okay. Okay, can everybody see my screen? Yes, just want to make sure. So yeah, I guess if there are problems, I will be checking let me kind of make sure I get my chat in here too. Let me get my chat because I'm using another screen. So let me bring my chat over. So kind of that way I'm seeing everybody. So welcome again, everybody, to my talk. And thanks for choosing my talk. You have, I think, 5 other tracks or so, something like that, right? And for you to come to mine. So thank you very much. My talk, again, it's right now on the screen, is about event messaging and streaming with Apache Pulsar. I don't know if I can actually see everybody's response, but if you have worked with Pulsar before, if you can let me know, that would be great, on the chat, or either you have worked with it, just let me know you've worked with it, or if you have heard of it and curious about it. Right now, I cannot do a poll. Sometimes I go to conferences, I would just do a poll and ask how many of you have heard of Pulsar, how many of you have worked with it. I just want to get a general sense and to kind of see where everybody is. But the thing is too, is that let me kind of clarify first too, this is an introductory level talk. So I'm going into some kind of introductory kind of conceptual terminology first before I get more into Pulsar. So I hope, for those of you who are already guru on this level, please bear with me. And of course, you're welcome to leave too if you don't find it is useful. So just wanted to kind of get a sense. And thank you. I'm starting to see folks responding to my question. So a lot of you, seems like it's you haven't worked with it, haven't used it, just curious and never used it. And I think one person's using Pulsar as a beginner. So that's great. So thank you very much. And again, maybe some of you are already familiar, so bear with me first. And I really appreciate you coming. It is true. This is sort of like a better alternative, let me put it that way, to Kafka, to event messaging and event streaming. So let me tell you how, right? So kind of curious about. All right. So again, let me kind of go. Oh, first of all, too, before I go, further ahead right now, if you are interested in this slide deck, please feel free to quickly scan it. I have a QR code, also the bit.ly link, if you want to, take a look at it while I'm presenting. I'm sure some of you are, wanting to have the slides with you and then page back and forth and control it yourself too. So please feel free to do it. If you somehow have missed it, don't worry about it because I'll be sharing my Discord server if you want to join me on my Discord afterwards or even now. Well, actually, then I have to give you the link. So that's actually towards the end of my talk. I'll share with you my Discord server and also my Twitter. If you follow me, I'll share it with you. So, all right, cool. I don't share it in presentation mode. Okay, your company is using it. Oh, somebody, okay. I don't share it in presentation mode. Oh, okay, all right. I'm sorry. Yeah, it's just, yeah, thank you. All right, so, okay, so let me go ahead. So who is Mary? Let me really quickly introduce myself. I'm a senior developer advocate at DataStax. This is a company that's still startup company, if you have been following, that's based in California in the US, although most of us are working remotely, like myself, I'm based in Chicago. And there are folks too, actually, also in Germany, in Italy, in other words, in the European Union too. Also in Asia, in Australia too, although kind of fewer in numbers, but yes, we do have folks pretty much all over the world too, pretty global. And if you have worked with Cassandra, you probably have heard of us because we are the one that provides Astra DB, which is the managed cloud platform for Cassandra. And now we also have streaming, which is kind of relatively new. It's only a year or so, a year and a half. So that's when I joined them. And previously I was with IBM. So I spoke here at JCON last year too, virtual conference. So if you came to my talk and come back again, thank you very much. And I was with the Java developer advocacy team before. And just a word too about developer advocates, because I've been asked many times, we actually, in my case, right, I was a developer before for like 20 years, specifically in Java as well, in that Java ecosystem. As we know, it kind of encompasses a lot of things, right? Not just the Java coding, but I do some full stack and then doing JavaScript, some HTML, CSS, you name it, and mobile, DevOps, all these things. So, but primarily I've been kind of immersed in Java previous to me becoming an advocate. And I've been an advocate for 4 years so far, and I really love it. So I'm also a Java champion. I'm also the president of the Chicago Java Users Group. So I'm really appreciating all of the community things going on, and especially here in JCON, very much of a Jug-centric, a lot of folks here, I'm sure you belong or you are members of some Java Users Group, or these days, you can actually join the Chicago Java Users Group, as a remote participant as well. So that's something about me. Okay, so that's me. And then, I also have on these slides, I also have my Discord. So if you want to join me there as well, and follow me on Twitter or LinkedIn. This is actually just a quick slide just describing me pictorially from my company, DataStack. So I just thought I'd quickly show it. Just wanted to point out my interest too, in terms of technology area. I've always been interested in distributed systems, messaging. And so now naturally getting into streaming, event streaming, reactive systems was also what I did before at IBM, and also some IoT and MQTT as well. So that's me. And so let me start, I talk enough. So I wanted again to start with a bit more of an, let me see. I'm sorry. Somebody is saying that you're only seeing slide 33. Really? That is so strange. Okay, thank you. I'm sorry. This is strange because let me stop share right now. And let me share it again. Share it. I'm sharing you know what I'll do? Let me share my Google Chrome, which is where I'm running. Okay, can you see me okay now? Let me also go back to getting my chat too. Now you can see, okay. Oh yeah, thank you. I think it's Venkata. Thank you for your comment. So, okay, I'm so sorry. So let me go back, but I think it's because this might be because of, let me go back then. I'm very sorry. I didn't know I should have read the comments a little sooner. So yeah, let me give you like a minute if you want to quickly scan or copy down the bit.ly code. Yeah. And I'm not sure. I think also is because the way the setup here is in Zoom, we're in a breakout room. I wonder when I share it, if it might be, if I share a whole desktop, it might not have actually shared, properly. But when I share only my Google Chrome where I'm running my Google slide, then you can see. So, okay. So, all right, without further ado, if you need it, you can get it later. And this is my slides. And then if you want to quickly kind of take a look, right, my Discord, if you want to follow me, but I'll share all of these connection information towards the end of my talk too, pretty much at the end of my talk. So, okay, that's me. And then again, my agenda for today, I'll just go into some basic concepts first, right? About event streaming, event processing, complex event processing, and then event-driven messaging, message-driven messaging, PubSub queue, all of these, let's clarify that first. And again, if you're already familiar with it, please bear with me. And then also, I wanted to kind of point out why event streaming, right? How can it, ultimately is that, yes, it seems cool, but the thing is, it has to have some value for us. So what is the purpose of it, right? And then I'll bring to you your attention to Apache Pulsar, talk a bit about more Pulsar, and also why you want to have something like Pulsar versus maybe the older like Kafka. Kafka is still very useful, don't get me wrong, but just Pulsar is poised to be the event streaming platform in the cloud environment. So that's what I want to kind of point out. Okay, let me start. So first of all, right, we're talking about events. I wanted to kind of set the stage first because I'm finding that when people talk about events, it can mean different things, and I just want to set the stage in here. So for us, right, we are talking about events essentially too. If I look up the dictionary, it is about, something that just occur. It's an occurrence. So in a computing sense too, if we kind of look at the theory of relativity, right, we look into the world as not just three-dimensional, but four-dimensional, right, or multi-dimensional. Basically, we have the, X, Y, Z coordinate. If you're mathematically inclined, right, that's the place kind of coordinates of place, right? X, Y, Z coordinate. But the thing with event is more interesting because it has the time aspect to it. So then you know that your data doesn't stay in one place usually, right? It travels through time, and then you have to actually track, if we're computer people, we need to be tracking the state changes at all times, all of these things for whatever purpose we're trying to do. So we basically are talking about events about the four multi-dimensional data traveling through time. And it's actually more complicated, right? And we live in not a simple world, as we all know, right? And we all doing different things. We're, all kind of somehow, right? To me, I'm always kind of fascinated by the fact that we are all traveling, doing something, right, at any point in time, but nobody somehow is doing everything at the same time, the same thing at the same time. Is kind of the amazing thing. I think is the law of nature, something like that. But anyway, not going to go into that. But the fact is that from a computing point of view, we are kind of looking at events at they are like data points in the system. We're going to start thinking of systems, and then streams are basically delivery and ongoing delivery of these events, right? So different kind of data kind of traveling through time, and a series of events, essentially, that's what we call is the streaming data or data streams, right? So it can also mean different things to different people. One thing I do want to point out is that I've been actually asked by people, can you use, what I'm going to talk about, can you use it for doing audio and video streaming? Yes, it is also about data streaming, but audio video streaming is slightly different. Their requirements are different because you need to render, right? Like the voice, the sound, something that is more, audio visual coming out of the output. It actually does require a certain amount of synchronous kind of processing. So it cannot be, what I'm going to talk about is really more applied to data, to processing the data rather than audio and visual. So not the same thing. Okay, and now complex event processing. So as such, right, we're doing all of these gathering of all the data that are traveling through time, but we need to make something out of it. Not just like, okay, we're doing it for fun or mechanically, we do something and it's there. But what is it for, right? So the thing is, complex event processing is talking about gathering all of these data and analyze them, basically deriving some value out of it. So for example, you can be using it for fraud detection system. I think the first and foremost, I would think most important thing, right, in living in today's world, that, your bank account is always being kind of under, kind of anybody, who is like quick to try to commit a crime. They want to actually, steal your data from your bank account, for example. So fraud detection system is a prime candidate for this type of system because we're talking about all of these things, data that's changing in time, traveling in time. There's data at rest, data in motion, right? And all of these things. So the thing is, complex event processing is gathering all of these data and analyze them, right? And for example, in your fraud detection, for example, like with your bank account, you need to be monitoring something, activities on your bank account. So if anything is unusual in the change of data, you need to be notified. That's very important. So that's dealing with complex event processing. So that's one case, but the other cases you can use for in today's world will be like for real-time analysis, real-time analytics, right? You want to derive some value as the data arrives. For example, right, I recently have done a talk with Startree. This company is also based in California. They do Apache Pinot. And if you're aware of it, Apache Pinot is a real-time analytics platform that's kind of online. They call it OLAP, right? Online analytics processing system. And so they actually have their own specific algorithms, and they are growing in popularity. And also they are actually the ones that are the power behind when you have your LinkedIn account, I'm sure. All of the feeds that you're coming in real time, for example, how many times your profile gets viewed, things like that. That's actually all using Apache Pinot. So, okay, so I'm talking about that. It's basically complex event processing. They still rely on source of data coming from some, real-time system that they are ingesting the data from. Then they can go through the data processing through their analytics machine like that. So that will be also another example of a complex event processing system. You want to derive some value out of it, right? To kind of allows, your applications basically to respond to events, to change, in the trends and also the patterns of data as they happen. So, Okay, so now then let's kind of turn back a bit into more messaging, right? So messaging, we're talking about, right, point kind of sender and receiver. It usually, right, that's what we're referring to. It's always kind of passing of data between sender and receiver. So there's event-driven. So event-driven too, very often we're talking about sender sending messages without knowing who they are going to send the messages to, who are going to receive on the other end. In fact, the producer doesn't even care. So in some ways too, we're talking about event-driven is a pub/sub type of scenario. And basically, whoever is interested, you need to subscribe to the messages, through kind of label of like a topic or like channel, for example. So in Pulsar, we're using topic. It's like Kafka too. They are topics, right? You label these messages. So that's more event-driven. And then, it's more one-to-many, but also too doesn't care about addressing, but it's basically handled by the broker that's in between. Now, then there's also message-driven messaging. So for that too, we're referring to point-to-point, sender and receiver, they have to know each other. So the address needs to be known to each other. That's point-to-point. So that's it. This definition too, for FYI, I took it from the Lightband company that makes Scala and not Scala, Akka, right? And also Dr. Martin Odersky, who's the inventor of Akka with his team. So and they are kind of the reactive technology giants in there. So they define, and they define this, and I thought that makes a lot of sense. So. Okay, so now then we're talking about event-driven. So if we don't use event-driven approach, what would we use, right? So the thing is, we know that in companies, and also too, the fact is not everything is suited for using event-driven approach, right? And for example, you are working for a company, large company, you have employee record system. So those are kind of system of records, they change, but it's not urgent. So those kind of things, you can actually batch them up, right? And I'm sure a lot of us too are still working with batch related systems, at some point, one point or the other, right? So batch processing is something that you don't take up too much kind of resources during, critical time. During critical time of the day, you want to kind of have instant processing of more urgent and time critical type of applications and systems. So in some ways too, they juxtapose each other, but they all serve different purposes within an organization, right? Okay, so now let's take a look into event messaging and the semantics and the patterns. I actually talk about event-driven messaging, so now it leads kind of into the pub/sub pattern. So if you think of it, pub/sub too, let's try to understand, it's more of an architectural design. It's not something that dictates how you do things. It's more like a architectural guidelines, I should say, conceptual pattern, right? And so it's up to the vendors or some libraries, they can actually define their own way of doing pub/sub because as such it's complex, right? But the fundamental kind of concepts is here. So pub/sub is essentially the ones when we talk about streaming, normally too, then that's when we kind of refer to the pub/sub pattern in which you have a publishing client, the one that's producing messages, and it doesn't care about who is going to receive the messages. And then it's relying on a middleman, middle person, middle agent to kind of take care of delivery of the messages. And all the producer needs to do is to basically label the messages. So in Pulsar's case or Kafka, we're calling it a topic. We're publishing messages to some topic. And then the broker, right? Essentially, this broker is like a post office, postmaster there to kind of distribute the messages accordingly. Now, I'm just talking about something very basic, but in reality too, this messaging, a lot of rules can be applied, right? You can have messages, do we want to retain the messages, time to live, message expiry, if it doesn't get delivered, what do you want to do? All these things, right? They are kind of managed by your broker too. So broker actually assumes a very important role in this pub/sub type of paradigm, right? Okay, so we talk about publishing, broker. Then on the receiving side will be the subscriber client. I'm calling subscriber because it's like me, if I'm interested in these messages, I'll subscribe to the topic or subscribe to a channel. Channel is actually used by microprofile, by the way, if you want to know about it. So, but they kind of serve the same purposes, basically labeling the messages and essentially tells how the messages are to be routed, right? So, okay, so that's pub/sub in a nutshell. Now, then turns into another kind of paradigm is about message queue, right? So queue is about one-to-one, kind of point-to-point, and they kind of interesting too. If you are a Java developer, I'm sure you've worked with data structure. It works kind of like the queue, right? When we learn about it, all kinds of data structures, this is a queuing kind of data structure. And it is also a form of asynchronous service to service kind of communication. Is used for serverless and microservices architecture primarily. And just like PubSub too, the thing about these paradigms is basically you're decoupling the sender and the receiver. So you can actually scale it quite easily. Now, in message queuing case is that it's only one-to-one. So basically what it means is that you're sending your messages to a queue. So essentially too, it's only one consumer. Once the consumer consumes these messages, then it gets removed off the queue. So that's the differences. Now, in a PubSub kind of cases too, actually very often too, for example, in Pulsar, unless your client acknowledge the messages will actually remain there too. But then Pulsar itself also have a mechanism of moving it off, kind of offload too as well. But I just kind of want to point this out, right? Message queue is that once you pick up, messages are gone. Whereas PubSub, the messages will be retained, for further kind of, you can do replay, things like that too. Okay, so now then talk a bit then about event streaming. So it's really a step beyond just event messaging. And what is driving this change is basically it enables like real-time data. That's kind of one of the primary kind of advantages of using event streaming, because now you're having messages that comes and it goes through the broker and gets delivered to receiving end pretty much, depending on how you're setting, right? Usually you can do it in real time. And that's one huge advantage. And it also, if it allows you to develop systems that you can better serve your customers, that responds to their needs kind of immediately almost, right? And then another advantages of using real-time kind of event streaming is basically to help you to build data pipelines. So very often too, we use this diagram of illustrating you have your source data coming in, and then you can also then transform your data too. And I'll talk a bit too with Pulsar. You can use Pulsar function to help to transform the data. And then what to do with your output, right? So what is called a sink, right? So you kind of deposit your data into a sink. Now from that kind of way of constructing your data flow, you can actually have multiple data pipelines being linked together, and they all can be written in different languages as well. And that's actually a big plus, right? So that's one thing. And then another application of such is if you're doing artificial intelligence or machine learning type of applications, you want to have quick turnaround. You want to be able to, analyze your data right away and then basically update your model, right? You can analyze it, update your model, and immediately use the data and deploy it right away. And as soon as data comes in, and then you go through that cycle. So that's kind of another kind of big advantage of if you want to use an event streaming approach that will help you with the real-time, building out real-time data pipelines usages for AI and ML type of applications or ML ops, right? And then another kind of huge advantage too is with scalability. Think of the fact that now with a PubSub type of scenario, you have tons of data coming in. For example, in Internet of Things, right, IoT devices can be scattered throughout a farm, a huge field, and here in the US we talk about acres, so it's a couple of thousand acres, huge fields. You can have different devices installed in your fields and collecting some kind of weather samples, for example, temperature changes, and then you need to alert the farmer to do certain things, right? So that type of stuff, you actually want to use a PubSub approach because all of it is collecting data and they immediately send the data to your server, whatever it is. And it's basically, you can increase the number of your devices without actually overloading your entire system. But of course, too, then on the back end side, we also have brokers that we can have multiple brokers to handle all of these things. And I'll be talking about it too. So those are kind of like the three major reasons why you want to consider using event streaming. So this is just a summary. So basically, it allows you to watch for events with the system or the application and helps you to subscribe to topics that are interested to you only, kind of filter off the messages, and helps you essentially make decision in real time, not after the event, and helps you to ingest high frequency of data with very low latency, very quick response. And this one too, just to show you, right? Streaming versus not streaming. So kind of take a look into here, right? If you use streaming, you ingest data and you process the data, and then you deposit the data into a sink. And then over there too, then you can have the sink, right? Have the new kind of like data sink, essentially. I can kind of describe this. You ingest data, let's say from a Pulsar source, process it, and then it deposit into, for example, a Kafka sink. Yeah, we have such too in Pulsar. So in that case too, you can feed the data into Kafka too. So in that case, as you can see, this kind of allows it to do it. Now, the thing is, more traditional way of not using streaming, you ingest data, you usually then you persist the data to some database, right? And then you will have to do selection from the database and do whatever you need, process the data, and then writes it back into the database and persist the data, and then so on and so forth. So as you can see, this kind of, kind of going between like external storage and then with your processor, all that, in memory, it can take up more time. It's kind of, as it's not as fast. But whereas, ingesting data in stream, you can actually do things in memory as well. So that's kind of an example. Okay, now then let me introduce to you Apache Pulsar. So what is Pulsar, right? It's an open source project, Apache Software Foundation project. Started by Yahoo. Yahoo at the time in early 2010s, they are already into the cloud, early stage of all of the cloud. And before cloud native, the term got kind of set up or coined too. And they dealing with tons of data, as we know, Yahoo News, Yahoo Finances, all these things. And they realized that whatever they had at the time, all of the event streaming platforms are not able to handle the huge amounts of data. Plus, also they need to be existing in the cloud. And as we know, when we operate data in the cloud, it's more complex, right? We're dealing with clusters. If you need to scale your whole infrastructure, you need to add nodes to it, add servers, all of these things, and you need to rebalance all of these things. So it's not easy to do. So that's when Yahoo slowly started coming up with the idea of Pulsar. They donated in 2016. And then quickly, too, less than 2 years, it already became a top level project because everybody is realizing that, well, we need a system like that to do streaming, messaging, fast, responsive real-time data, and in the cloud. And so very much so is that Pulsar is designed with the cloud native kind of in its design. So I call it like it has cloud native is in its DNA, right? So like that. So cluster-based, and also multi-tenancy. Multi-tenancy is a way of you kind of dividing up better managing your data according to functions, for example, things like that. So it organizes data for you too. And also too, the client APIs are relatively simple, right? You connect, you set up your client. It's pretty much set up your client, and then with your client handle, you can then have set up your producer and then basically produce your messages pretty much, right, in summary. And then consumer is the same thing. You set up your client handle and then set up your consumer and then receive your messages or acknowledge it, all of these things. So now the thing is with client API is that the nice thing is with Pulsar, for example, it supports Java. The broker is written in Java, it's all Java. But the thing is, you can also have, besides Java client, you can use .NET. If you're a .NET developer, right, you can use C# and also, for example, Python, Go, and also there are community contributions too. For example, in Scala client, somebody asked me, in fact, there is contribution in Scala client too. There are also Ruby and other ones too that you can also check to see what is being supported. And about Pulsar too, one kind of big advantage of it is that it separates out the compute and the storage. Now, as such, with huge kind of this type of messaging systems, we're dealing with tons of messages flowing through your system and what to do with your messages, right? So Pulsar is smart enough to say that, well, you know what, handling the storage of data or large volumes of log messages is not our thing. So let's delegate it. So they pick Apache Bookkeeper, is another Apache project, right? The Bookkeeper's, that's its strength, is to manage huge amounts of data, write it to disk and verify that it is keep its integrity. And then for fast read and write and the ledgers, all of these things, it's much like an online accounting kind of book ledger kind of system. So Pulsar relies on that. So you see that is actually an advantage in a cloud native world. And then another thing about Pulsar is that it knows how to guarantee your message delivery. As we know, right, async messaging, you send the messages, how do you know it gets delivered, right? And what if the network goes down? fear not. Pulsar has this built-in capability of knowing that you want, you send out your messages. It's like the post office. We guarantee delivery. Don't worry about it. Network goes down, we'll handle it, and we'll deliver it when the network comes back. Then there's also this serverless functions framework that I kind of show you, right? Data pipeline, you go through source and then go through processing. You can use third-party library to transform your data, but why do so if Pulsar already has a function, a lightweight function framework that you can do? I'll quickly show you how you write a simple function to afterwards, right? And okay, so and basically, so we have that. And also, too, I mentioned about how, Pulsar also manages data if it becomes kind of cold, right? So basically, you have tons of messages going through your system, flowing through. And sometimes some messages are already sitting there. It may be not acknowledged yet. Now, that's another complex thing, but I won't go into detail. Maybe I'll do another talk over it. It's basically about message expiry, time to live, all of these things. Now, it's a complex thing. But the point I'm trying to make in here for the tiered storage offloads is that you have data that's kind of sitting in hot storage, right? So let's say they already been processed, they've been acknowledged, you need to move them off of code and long-term storage. Pulsar has this built-in capability of recognizing that and moving the data off, to cold storage for you too. So it's overall, Pulsar is a very flexible system, but of course it is new, but it really has the best intention and helping developers out, especially all the infrastructural concern. Pulsar will take care of it for you. Okay, so this is just a quick diagram to show you too. Basically, there are 3 graphs I'm showing you. Is that Apache Pulsar, GitHub stars are kind of increasing. It's basically people are recognizing it. More people are welcoming to kind of work with it and kind of contribute to it too. Because as such, right, there's still a lot of work to be done. And who else is using Pulsar? So these are just a couple of logos, as you can see in here. So these are big companies like Yahoo and Overstock and Verizon. Also a couple companies in China as well. They're also into doing this. In fact, the Pulsar project also has a lot of mainland Chinese developers working on it too. And so Pulsar is different. Again, this kind of summarizes, right? If you kind of look at Pulsar, what is it, right? So essentially, when you write code, you're writing to either the producer or the consumer, pretty much, right? And you rely on a broker. The broker is a stateless process that handles all of the incoming messages, process it and communicates with the Pulsar configuration store, work with the bookkeeper, because bookkeeper is the one that manages all of the back-end storages, all of these things. So it's the broker's responsibility. So broker assumes a very important role in this ecosystem. And then, of course, broker also deliver messages, right? That's the important thing. And then there's Bookkeeper that helps you with managing persistent message store. And also, Pulsar also uses Zookeeper for managing, in terms of the cluster and metadata, different Pulsar clusters and coordination of these. So currently, Pulsar is using Zookeeper. And Pulsar has a traditional multi-node architecture. So basically, too, if you think of it, you are doing horizontal scaling, meaning you need increasing capability in your cloud infrastructure. You are, instead of adding more disk space maybe to your server, you're going to add server to it, or add a node, or add another cluster to your larger infrastructure. So all of these things, right? Think about it, right? You already have some brokers kind of handling things, and in some topics, permanent, maybe more persistent storages, persistent topic that needs to always be there. They are already scattered through, if they're partitioned topic, then they live under different cluster too. And if you add another cluster, you need to rebalance it. Now, the thing is with kind of, let's say, right, with Kafka, the way Kafka is handling is that you will have to take care of rebalancing your broker, all of the topics too. But then with Pulsar again, a very cloud native aware, then it knows it will rebalance all of these topics, spread them out for you in different cluster for you. So then it's less of a headache for you. So that's kind of a primary thing in here. And then another thing I want to just point out in here is essentially the Bookie. So Bookie is another name for bookkeeper. As you can see, right? And I won't go into all the details because it's another talk in itself, right? But so Bookkeeper essentially helps you to manage all of your log messages. There are so many of them. It's essentially too, it has a very organized way of handling these tons of log messages. breaks it up into different book keys. First of all, they are a unit of processing, right, within the Bookkeeper system. And each, book key has a storage, and then each set, it manages sets of data and through, storing them in different segments. So it's well organized too. And it's also, if you can see in here too, it supports this wall kind of specification is a write-ahead logging. So essentially, to summarize, it is a very fault-tolerant and low-latency storage services. It relies on like the journals, and it you can tune it for consistency for message replication. So overall, it is it's kind of a very efficient system for managing huge amounts of data for you in a very efficient way. You can read from it easily, write from it, and also safely kind of noticing that it is very safe. The data is being checked before it's being stored and all of these things. So never corrupt data too. Okay, so very, very quick recap is that Apache Pulsar represents the next generation of enterprise messaging. If you have a system, for example, you already have Kafka running, JMS, RabbitMQ, don't worry about it if you're not ready to, let's say, convert everything to Pulsar. Pulsar can be bolt on, right? So it's that flexible a solution. It's basically a unified solution for PubSub, for streaming, for queuing, and for message mediation and enrichment. So out of the box capabilities include, you can run it on the cloud or on-prem or hybrid too. And it supports also this feature called geo-replication. So that's also a huge advantage if you are, if you're managing or if you're running in in your ecosystem that involves multi-region geo-regions in the world. And there's also data lake integration, for example, OLAP integration, all of these things. Because of the PubSub data pipeline nature, you can actually literally connect to many things, right? And then without doing, well, the thing is that if you have native integration, of course, it's easier, but you can also write your own connectors too. So which is something I'll quickly show it to you shortly. Okay, so here, this is how is it Pulsar different? I think I already talked about it. We all know it's very flexible, tiered architecture, separates compute from storage, kind of a separation of concern type of system. And okay, so this too, I wanted to point out, right, some kind of huge key differentiator. Why do you want Pulsar? Essentially too, separation between compute and storage, which I talk about. So it helps too. The thing is, it helps with all of the scaling, right? If you need to add more service to it, all of these things, it actually makes it easier because then, okay, if you need to scale, you need to add things to it. Bookkeeper, do your thing, and Pulsar will do its thing with the broker side and all of these things, but the broker coordinates with the bookkeeper. So that's kind of in a nutshell. Secondly, the geo-replication. Now, if you have live right in your company, your workplace, having multiple data centers that span across the globe, in different geo regions. Let's say I like to use this example of in Europe, you have GDPR that deals with data. So, and then, it's also a common practice that companies, you need to replicate all of your data across different regions. But let's say GDPR's case, you do not want to, replicate certain data. So Pulsar also has this built-in capability for you to configure. So then you kind of do message replication like selectively too. So that's also another kind of good thing. And it supports all these different replication mode and patterns like synchronous versus asynchronous, active, passive, all of these things. You don't need to bring your cluster down when you're doing replication, all of these things. So it's really built for kind of quite easier in terms of managing things for you. And another kind of key differentiator about it is multi-tenancy. I mentioned about how you can separate out all of your functional data. For example, you have a company, you have, obviously, right, we have different departments, marketing department, product department, engineering, and we're handling different data for each individual department. And we don't want to mingle them all. You can actually use Pulsar's tenancy or tenant, multi-tenant support too. So that will also help you. And when I quickly show you Astra DB from DataStax, we actually can visually show you how you can quickly set up your tenants very easily too. And then another key differentiator is basically, in this case, is that we're talking about messaging, producing to a topic. But the thing is, in terms of the processing model on the subscription side, there are 4 modes. You can have it exclusive mode. So this will restrict to only one receiver, one consumer. So effectively, too, will turn Pulsar into a message queue. It's a one-to-one type of scenario. So you can kind of use Pulsar as a message queue in this sense. Now, another mode too will be called failover. It's like you have multiple consumers, but one will act as the primary. So if the primary goes down, then it will fail over to the secondary ones. But essentially, a lot of times you probably want 2 or 3, something, they will take over if the primary fails. And then there's also a third kind called shared subscription. Essentially, too, you can have many consumers subscribing, right, using the same subscription, and it's shared. Now, the thing is that's shared. Okay, it's very common and commonly used in a cloud native type of setting. The thing is, too, is that if you want to guarantee your message ordering, then you want to use the fourth type of mode, which is called key shared. So it's basically using the key for essentially ordering all of your messages. So when the message arrives and how it's being delivered to your consumer, that's also being kept in the order as it arrives too. So these are the 4 modes. Okay, so this one is about why Pulsar. I won't go into details. I'm already talking about it since we're short on time. But the thing is, I wanted to quickly talk about a couple features of Pulsar, about the data pipeline, right? So we have Pulsar function. So think of like function, right? Serves in this case is in the pipeline. You have data coming through from a faucet, flowing through the pipeline, and then it goes into, this is what we call a Pulsar function. It transforms the data accordingly, do whatever you need to do. And then when it's ready, it outputs the transformed data to a sink. So that's how we kind of describe a data pipeline, and you can build the data pipeline, multiple ones, all connected. They don't need to be writing. This I can be written in Java client. On the receiving side, it can be a sink, is basically, we're dealing with .NET as well. So very, very flexible kind of way of doing things. And here is just a quick kind of diagram showing you Pulsar function. You read from the same topics, you get all the messages, and you can kind of have one function that processes messages from different topics as well. And then you can output it to, kind of regular output topic or to log topic, all of these things. It's essentially function as a service, and is inspired by AWS Lambda, Google function, all of these things. It works kind of similarly and very lightweight too. Currently, though, it's supported only Java and Python and Go, but there are already plans and kind of efforts too in the community, or even in the, not just with the outside, well, I should say everybody's in the community. So there are already efforts in building other types of language support for Pulsar functions too. And now there's also another kind of capability called Pulsar schema. So as we all know, we're doing messaging, right, through the wire. So we need to serialize it before we send it, right? Flatten it, and then also then deserialize it when you receive it. So in Pulsar's case is that if you don't do anything with it, you essentially do need to convert your data into byte arrays. The thing is, though, we're always in our applications, we're dealing with more complex data, and they change over time, your data structure. How do you handle your business, right? So there's this capability, it's called Pulsar schema, I should say, actually, this feature, Pulsar schema. And basically, you can define your data in a schema. And also, in this case, you let Pulsar worry about the deserialization and serialization for you, right? And so it supports like primitive type, key value pair, Afro schema, and JSON and protobuf, right? Those are the included or supported data type for the schema. And also manages the versions of your change of your schema for you. So it's a very convenient type of feature. And then another thing too, is about, I talk about how you can actually write different sinks or write different sources. Now, Pulsar comes with some pre-configured sources and also sinks. If you want to be doing something that's outside of what they have currently, you can actually use Pulsar IO, this particular feature, and it has a development kit for you. But right now too, I believe it's only Java and a few languages too. You can actually write your own sink, write your own source, those connectors. So for example, sinks, currently we support, as I mentioned, Kafka sync, RabbitMQ sync, JDBC for Postgres, for example. But the thing is, if you want to do some other things that's kind of a bit of an archaic type of systems, for example, I got asked for Terracotta, right? It's a kind of older thing. And you can write your own sync, I mean, at least theoretically. So you can kind of look into using this to develop your own sync or kind of your own source as well. Okay, so I just want to, at this point, very quickly then point out DataStax, what we have to offer. So DataStax has a managed cloud called Astra DB for Cassandra, but now we also have Astra Streaming. So that's managed Pulsar underneath the hood. And then we are offering $25 US dollar per month for like free usage too. So I'll be sharing that link with you. And then there's also Luna streaming. If you want to manage your own cloud, using Helm chart to deploy your Pulsar, all of these, you can use Luna streaming. And then also if you need support, you can purchase our support. And then if you want to go all open source, is also there for you to use. So. And this one too, at DataStax too, we have different, we also have a data API layer. If you're already running Kafka, JMS, or RabbitMQ, you don't want to change things yet, you can actually leverage on the Starlight API, this layer to kind of connect with Pulsar as well. And here too, actually, this one I probably won't go into a lot of detail, but the thing is too, I want to point out to you, there's this feature called change data capture. I also have another talk on it. It's basically, if you're familiar with it too, it's basically detecting any changes in your tables, and then it will trigger some sort of, kind of trigger in the sense I'm just using that word as is, not like as a database trigger. But it functions like that. So then it sends some changes and it will send these changes. It's sort of like event, kind of notifying some actions to be done. And essentially too, CDC for Cassandra is actually enabled by using Pulsar underneath the hood. These are building all the data pipelines for you too. So there's on-prem, if you want to use Luna streaming, the on-prem, your own managing, you can use CDC for Cassandra. Or if you use Astra streaming, we also have CDC for Astra DB, which is our managed cloud platform too. So that's all. And these are just Luna streaming or Astra streaming from DataStax. And okay, this one this one I actually shouldn't have done it, but I want to do a really, really quick demo. Okay, so I hope, okay, wait, I think I might need to stop share. And then let me also then quickly reshare with you this one. This one, okay. Now, I just want to really quickly show you the DataStax, right? We have the Astra cloud platform and okay. So astra.datastax.com. You can sign up for free too. Over here, you don't need to give your credit card number. You just need to give your email address and your first name, last name, and then you can get an account. So in my case, I've already have an account. So if you once you sign up, it's really fast, right? Again, only ask for your first name, last name, and your email address. You can see the dashboard kind of a display in here. So as I mentioned, if you want to start playing around with Pulsar, you can quickly do create stream. I talk about a multi-tenant system already is set up that way that you can create, for example, JCON as your tenant name. You want to pick Amazon and picking, okay, this one is US East, that's fine. And then it shows you how much it costs, and then it will create the tenant for you, right? So again, this is kind of more like a demo kind of scenario. So let me also go in, and also while I'm here, I want to show you too, if you are into Cassandra, you can also play around with Cassandra using Astra DB. You can also do create database in here. So it's all for you, $25 US dollar credit to per month. And so $300 per year. And you'll find that it's actually quite sufficient too. This is what I found if you do personal projects. So in this case, I also have already have a topic in here I want to share. So I created my tenant. It's called POC tenant. And over here too, you can actually follow this in here. And getting started with Astra streaming, you get a set of instruction. How do you create a topic? So if you create a topic, it goes in here. And it's kind of simple, right? In this case, add a topic. You can be persistent topic or partition topic. All of these things is in here. And then let's go back here. I already have the topic. So if I want to write a producer, you can actually go here. Here we're talking about Java. So you click on Java. And basically, you look into here, your Maven kind of definition. What should you do? How do you write a producer? As I mentioned, the client API is not too complicated in the sense that you're just primarily doing Pulsar client, build it up, so set up your client handle, client object, and then essentially then can do client.newProducer to set up your producer. And then when you're ready, do a producer.send. And again, this one is not using Pulsar schema, so you do need to convert it to byte array. And then when you're done, do a Pulsar producer close and client close like that. So on consumer side too, it's kind of juxtapose each other, right? We're doing Pulsar client build, and then doing client, new consumer, subscribe, all of these things. And you can set up your subscription mode, for example. And then, of course, too, if you're subscribing in an async situation, you need to kind of already set up your subscriber. So then when the producer sends messages, you'll receive it, right? But make sure you're connecting to the right topic is right here, right? So again, you just wait for your messages. When it's received, you can acknowledge it like that. So, and then when you're done, close it, and then you're done. So this is just a quick super quick overview, but there's also a reader interface that I talk about, because reader interface essentially allow you to traverse your log messages too, which is like in Bookkeeper too. So, all right, so this is again just a real quick. I noticed my time is up, so I'll go back to my slides. And again, please sign up for this free account to start playing around with it. Okay. Here, so where to go from here, and I like to keep in touch. These are the resources. You can look at pulsar.apache.org, Bookkeeper, Zookeeper, and our astra.datastacks.com is where you can sign up for, get access to our Astra DB, Astra streaming too, and also all of these links for the resources on DataStax website. And then this is Astra DB with streaming. If you want to have additional $200 in credit, you can go to this link and then enter this code for your to get additional credit for it too. And then we also have 5 minutes about Pulsar on our YouTube channel on DataStax developers. So this is the link, and we're constantly producing new topics too. So there's only bite size. So if you need some kind of quick information, please check them out. They're very precise messages that you can kind of do a quick lookup. And also I have my own Twitch stream every Wednesday at 2 p.m., usually when I'm not traveling. So please join me, because now I don't have time to actually demonstrate code, but that's when I use my time on Twitch to do some code demo live streaming too. And then how do you start, right? Coding all of this. I introduced to you Pulsar, Astra streaming, for example, and then there's also Astra DB with Cassandra. We actually have a site here called Awesome Astra. This is the link, and you can go there. We give you guidelines and help you to jumpstart your journey in this space. And the thing is, you can start coding, and don't look at it like we're trying to kind of sell you something. No, it's all free. You can just use it anytime. So. And please join us at the hood, right? I call it for the Pulsar neighborhood, and also Pulsar. This one, Pulsar, Apache Pulsar neighborhood is a wiki page. You can contribute to that too. We invite you to join in. And with that, I want to say thank you. I'm like a little bit 2 minutes over time, but I want to thank all of you for having sat through my talk. And also, I think you also asked some question, and I apologize if I did not address it yet. Let me kind of really quick look. Oh, I'm sorry. Now I see I have 6 minutes left. Yeah, thank you. Thank you to my moderator, Zara. Okay, so let me see. A bunch of questions. Okay. Okay, I have Kurt DeWitt. What makes Pulsar different from Kafka streams? They seem very similar based on the information in the presentation. Yes, very, very true. Pulsar, again, I wanted to quickly point out is that because of the cloud native readiness of this whole design. So as you can see, right, it actually helps, when you have things already designed for that. Then on the infrastructural side, as we know, right, doing things in the cloud is not simple, because we're dealing with this heavy duty kind of, behind the scenes kind of infrastructural things. So Pulsar is kind of built with this awareness. So it knows how to manage all of these, cluster, more infrastructural stuff for you. So that's kind of one thing. And the separation of compute and storage too, that will be another thing too. So yeah, so hope that okay, Torsten answer, multi-tenant handling. Yes, I hope that quick example kind of show you, and also the tree structure, how I showed that you can actually do multi-tenancy quite easily too using Pulsar. CDC seems very similar to Debezium. Yes, it is. In fact, yeah, it's the same concept for change data capture pattern. Okay, Torsten, probably the possibility to choose the subscription mode. Yes, you can also use different subscription mode. For example, I mentioned about if you want to turn Pulsar for you to use it as a message queue, you can use exclusive mode, and that will turn into kind of a one-to-one kind of messaging paradigm in that case. Okay, yes, a breakout session. Yes. I'm sorry. Okay, that's not for me. Okay, all right. Okay. I don't share the slides. Yes, I share the slides. And does anybody need the slides? Or maybe please join me on my Discord. Yeah. So yeah, you're welcome, Ralph. And thank you, everyone. I think I'm probably time's up and my next speaker is here waiting, right? Yeah. Thank you, Zara. Thank you, everybody. I hope it's been helpful. So yeah.